For this assignment, I'm going to be cutting up an apple, and the first thing I do is pick up the knife and begin cutting the apple. Before I make the first cut, I use visual information to judge where the knife is compared to the apple and where the apple core is located. So light is reflecting off the apple, knife, and cutting board, and it enters my eyes. Photoreceptors in the retina convert that light into electrical signals, and those signals travel through the optic nerve to the thalamus and then to the primary visual cortex in the occipital lobe, which allows me to see what I'm doing. I'm gripping the knife as I'm cutting the apple, and so touch receptors in my skin are detecting pressure, texture, temperature, all of those things, and these receptors are especially dense and sensitive in the fingertips, and so this information travels along sensory nerve fibers in that area to the spinal cord and then upward to the thalamus and the somatosensory cortex. At the same time, proprioception helps my nervous system track where my arms, hands, and fingers are in space, so just where your body is. And there are these specialized receptors called muscle spindles that sense the extent and speed of muscle stretch, along with Golgi tendon organs detecting muscle tension. And so this feedback helps me position the knife just outside of the apple core where I want it instead of cutting right through the center. Now, I'm able to make these decisions because the frontal lobes of the brain are involved in planning and decision making, so they help me determine my intended action. So that's slicing the apple in a specific spot, as well as the motor cortex, which is also located in the frontal lobe. It formulates the commands that direct my body parts to move. I cut downward into the apple. These motor commands travel from my brain down the spinal cord to alpha motor neurons, and these alpha motor neurons extend out of the spinal cord and send signals to the muscles in my hand, arms, and shoulder. And these muscles contract so that I can grip the apple, hold the knife, and push the blade down through the apple. When I feel the tip of the knife hit the cutting board, sensory feedback tells my nervous system that the knife has reached the bottom, and I adjust the movement from pressing straight down to rocking the knife backwards and cutting at an angle. So this adjustment depends on coordination, and the basal ganglia helps facilitate voluntary movement, while the cerebellum helps fine-tune the movement and the timing of everything. So the cerebellum receives sensory input from the limbs and integrates it with the motor commands, helping to make sure that the timing and force of the movement are in tune with each other. So, for example, if the apple is harder to cut than expected, the cerebellum helps me adjust and apply the correct amount of extra force. Overall, this process is very complex, and something as simple as cutting an apple shows how all these systems work together to create controlled movement.